Hello and welcome to the Chapter 7 video on Minitab Express to calculate normal probabilities. So just as a reminder, this is just how to do some calculations once you already have the distribution. Once again, since there is no data involved and I'm just using Minitab to do some calculations for me, I don't need the data. So I'm going to change my navigation to show output only. I am going to leave the navigator in place in case I need to go back to previous calculations. If you don't think you're going to go back, you can always turn the navigator off. This is usually the default with Minitab Express. So let's look at this first problem. Well, it's the only problem. This video is very short because, well, everything we're going to do today is the exact same stuff from Chapter 6, it's just on a different distribution, a continuous one, the normal distribution, which is always bell-shaped, unimodal, and symmetric, because that's how it looks. So, assume the speed of vehicles along a stretch of I-10 has approximately a normal distribution with mean of 71 miles per hour and a standard deviation of 8 miles per hour. This is actual real data from about 4 years ago. I believe this stretch is in Ohio. I think. I really should have written this down and put it on here because, clarity is always better when citing your sources. Anyway, so since we know it's approximately normal, we know the mean, and we know the standard deviation, this is enough to know exactly what this looks like. So, the current speed limit on this is 65 miles per hour. What proportion of vehicles, this should be go or travel or something, there's missing a word, less than or equal to the speed limit? So what we're interested in here, and I can use any variable I want. So I think, since this is speed, I don't want to use S because that's usually used for standard deviation. Oh no. Oh well, I guess I'm going to use X. I want to look at going less than the speed limit, so 65 miles per hour. Now, if you're looking at this and thinking, well, is this less than or equal to? Remember, with the normal distribution, that actually doesn't matter since it's continuous. And this is the big difference between it and the binomial and the geometric. In the binomial and the geometric, your variable is counting something, and they're ones that can't have parts. So when I mean that, I mean when you look back at the example video from Chapter 6, we were doing candies. I'm sorry, that was the homework assignment. We were doing candies and we were counting marbles. You can't have part of a marble. Well, you can, but okay. You can't count part of a marble. So you either have 6 of them, or you have 5, or you have 4, or you have 3, or you have 2, or you have 1. You might have none. But you can't have, 6.753 of them. When it comes to speed limits, yes, you can go speeds that are not whole numbers. This is the difference between continuous data and discrete data. So one of the common questions I like to ask students is, okay, it's 65 miles per hour. What's the speed right before 65? Just below it that's going to be a part of this. And most students or most people will answer, well, it's 65.9. But that's not it, because 65.99 is closer, and then 65.999 is closer, and 65.99999 is closer. And I'm tired of saying nines now, but you get the idea of you can put as many nines out to infinity as you want to, and it gets you closer. So how far away are you in that case? Well, I should have said 64, I just realized that. Yep. So how close are you? Well, you're 0.01 away, or you're 0.001 away, or 0.00001 away. So close that that 1 can go out to infinity, and you're not really that far away at all, because it looks like you're not far away. You're 0. You're right next to it. You're actually the same value. So what's interesting about this is you can't say what's next, but you can always do that with something that's discrete. Anyway, so we're going to look at being less than 65 miles per hour. So just like we saw with Chapter 6, we're going to go to statistics. You can use the CDF PDF to do this. Just as a pro tip, you will never use PDF on the normal distribution. You will only use CDF. I'm not going to use it at all. I'm going to use the distribution plot and use display probability. Now this one defaults to the normal, and notice it defaults to the standard normal, aka the normal with mean 0 and standard deviation 1. This is the same normal that you have a table for. We don't have one that's mean 0. Our mean is 71 miles per hour. And our standard deviation is 8 miles per hour. And in particular, we're looking at speeds that are less than 65. So I have an x, it's 65, and I want the stuff less than it. So all numbers, that's one way you can read a variable. I want the probability that I'm looking at a speed or any speed that is smaller than 65. So things that are smaller than 65 on the number line would lie to the left of it. And that's why this will be a left tail. So if you imagine the x being a 65, you're looking at all the things to the left of it on the number line. Because this is a axis, it's all the stuff below it. And then we'll hit OK. Alrighty, and just like when we were doing the geometric and the binomial, the probability appears above the area of interest. The area of interest that makes our probability is coded in red. Now, when you're getting these values, I always suggest you check your distribution to make sure it's correct. So make sure your mean and standard deviation match what is in the problem, because if these aren't right, well, then you're definitely not going to get the right probability. So it appears my answer is 0.226627. And that's it. Done. All right. What's the probability that someone's going to be going less than 65 miles, than 50 miles per hour, because I can read. Oh boy. I really need to work on my self-deprecation. So exact same idea, except for my value of interest is different. It's no longer 65 miles per hour, but 50. So I'm just going to hit the make similar button. And then the only thing I need to change is this x value into being a 50. So everything's the same except for that. We're going to hit OK. And there we go, much tinier. But that makes sense, because when you think about how far 50 is away from 71, which is the average or typical value, this should be small. Now, don't forget, it's not just how far, but how things are measured, because your value size could be very, very far away, but yet seem very close. What do I mean by that? So if you look at salaries measured in thousands of dollars, then looking at somebody who makes $65,000 is very close to somebody who makes $64,000. But if you were measuring in like just whole dollars, not thousands, because then it would be 65 and 63, you'd be looking at somebody who's over 1,000 away. So distance is relative to how you're measuring. How do you measure with the normal distribution? Well, that's just center. How you measure is spread, or standard deviation, 8. So when you look at 50, how many standard deviations is it away from 71? Well, a little bit more than 2. So what I'm doing is I'm taking 71, I'm subtracting 8, that brings me about to 60, and I subtract 8 more, that brings me almost to 50. So it's at least 2 away. Actually, when you look at it, it's much further than that. So, and I was just estimating. So it's tiny. Oh my gosh, my mic almost fell off. I might need to cut that. All right, so what portion of vehicles are going to be going more than 80? These are the people who like pass you going real fast, because this is a 65, remember. So we're going to go over 80 miles per hour. Remember, over or going more than should be a greater than. So I want to go the other direction. So I want speeds that are greater than 80 miles per hour. So it's no longer going to be a left like the previous two were. It's going to be a right. So I'm going to hit make similar again. And then make the changes I need to get a greater than. So I want stuff to the right. And I want to change this to an 80. Notice that make similar button makes this much faster. Let's go ahead and hit OK. Alrighty, there we are. 0.130295. So about 13% of people go over 80 miles per hour on this stretch of highway in particular. Whew. That's interesting. Cool. So let's suppose a researcher wants to know what values make up the middle 80% of speeds. So I'm going to make this have just a little bit more space to prepare something here. Sorry, I had to get my inking prepared. So, I want to draw a picture of what's happening here. So we got our normal distribution. The center is 71. I'm just drawing out what my distribution looks like. And I want the middle 80% of all data. So I want to round the center so that this area right here is 80%, or 0.08. Or I want this area in the center to be 0.8. So I have some cutoffs that are hopefully symmetric, since this is symmetric. And I don't know what this value is, and I don't know what this value is. But I want to know what they are. Actually, let me do double question marks so these look different. I'm going to show you a couple different ways to do this. So if this doesn't like to do points. Sorry, if this is 0.8, then if you know that the total area under the curve has to be 1, then in these two tails is zero point 0.2 so that it sums to 1. Or if you want in just one tail, it'll be 0.1. That's supposed to be a 1. Doesn't look like a 1, sorry. This tail 0.1. And if I'd drawn this perfect, then this would be completely symmetric and it'd look the same on both sides. The difference being that obviously one of these values of interest here, this question mark number 1 and this question mark number 2, one of them is going to be below 71, other one's going to be above, and they're going to be the same distance apart. All right, so what I'm really saying is I don't know the values. I don't know what question mark number 1 is, but I do know, or what question mark number 2 is for that matter, that when I look at the probability that I'm between those two values, I get, can I go this over a little? Oh, it doesn't want to listen to my mic. Whoop, I'm hitting buttons. It's gonna be 0.8, yeah, or 80%. So I know a probability, I don't know a score. So this is backwards from all the other problems that we've done. So let me show you how to do that. But if the picture makes sense, this should be pretty understandable. So I'm going to hit the Make Similar button. The only reason I'm using Make Similar this time is because it keeps my mean and standard deviation 71 and 8, so I'm on the right distribution. And notice what I'm communicating is the opposite of what done before. I've always been, starting with an x value and finding a probability. Here I know a probability, I have to find an x value, and I know where the probability is at. So I have to communicate two things here. Not just what direction or place I want based on the x value. I need to communicate what my probability is and where it's located at. So the first way you could do that, well, the first thing you need to do, is go to, I know probability, so I need to change this radial dot to specify probability. Then the next thing I need to do is I need to pick a picture to match this. So this is where this gets a little complicated and why I labeled all these parts. So you might be tempted to pick equal tails. You might be tempted to pick middle. These actually both will work. I'm going to show you both just so you can see how to do both. I'm going to start off by doing equal tails because actually the one I like for doing this type of problem. And it does give you the correct answer, but it doesn't match what you're picturing exactly. So equal tails, and it's going to split the probability between each of them. That's what this p over 2 is telling you on each side. Whatever probability you give it, it's going to split in half into the two. That's why I brought up the fact that together these make 20% because it's going to split it in between the two of them. So I got to put 0.2 in here. All right. And it's going to do the split for you. That's why you're giving what's in both tails, hence the whole equal tails part. Let's hit OK. All right, so there's our two speeds. So it's between, is it going to let me type on here now? Probably. Okay, hold on. I'm going to pause this till I can make, sorry about that. I was trying to get this thing to not mess up my picture so that I could write something. So the speeds it'll be between to give us the middle 80%. So I would write this as the central 80% is speeds between 60.7476 and 81.2524 miles per hour. It's good always to include your units. Okay, so that's one way to do it. Now, the dissatisfying part about this picture is clearly the area it's using is the tails, not the stuff in the center. So if you are a stickler for my picture has to match exactly what I'm doing, even though this is counting up for the same stuff, here's how you do that. So I'm going to hit Make Similar. I'm going to do Middle. Now, middle's unusual because it has probably 1, probability 2, and it wants the probability of the stuff to the left of the area of your interest, and the probability 2 is the stuff to the right of your area of interest. Now, in my case, the stuff to the left of my area of interest is this 0.1 tail, and the stuff to the right of my area of interest is this other 0.1 tail. So they happen to be the same. 0.1. Whoop, sorry, I hit the negative sign, not the 0. My bad. And 0.1. And this one will actually match the picture you expect, but it gives you the exact same answer. Ta-da! So like I said, exact same values of interest, but notice this picture matches what you might expect. Oh, I've got this area that's in the middle. The red stuff is the area that makes the probability, and the probability value is 0.8. So that's how it is. Cool. I'm going to hit enter to put this on the next page. Come on. I always feel like I'm encouraging Microsoft Word to listen to me. All right, so here I want to know, they want to make a new speed limit, so they want only the top 15% of vehicles to be considered over the speed limit. What is the new speed limit based on this criteria? So looking at this, one of the things we knew from the problem before is this is 10% left in this upper tail, and that's 81 miles per hour. So it's going to be somewhere between 81 and 70, but that's about all you can estimate it now for right now. So I want the probability that when I look at speeds over my unknown speed, which I'm going to call 3 question marks, I've already used 1 and 2, I get the top 15%. And that's how I know it's a greater than. I am having a hard time with my 0 today. It's sticking a little. There we go. So if you were to draw a picture of this, so the picture for this one does look different. Uh-oh. Come on, pen. There she goes. Oh, it's green today. All right, well, that's fun. So that's roughly reset. Center is 71 miles per hour. Oh, so I don't know what question mark triple is, but I know the area of interest above it is going to be right here. It's not letting me use the highlight. There it comes. All right, the lag on this is making it real fun. And that area. Oh, this is one of the beautiful tools that's great when it works, but when it doesn't work, it's super frustrating. It's not recognizing my pen. Okay, let's pretend. Oh, there we kind of go. Now I'm doing it with my mouse. It looks terrible. That's 0.15. Yay. Okay, you get the idea. Oh, wrong button. Back to home. Okay, so you get the idea of what the picture is. Let's see how to do it on Minitab. So once again, I'm going to hit the Make Similar button. Keep me on the same distribution. Here I want a upper area, so I'm going to be picking a right tail, and that area is going to be 15 miles. 15 miles per hour. 15%. Ooh, okay. And then we're going to hit OK. I got some editing to do on this. I shouldn't have said that out loud because I'm going to have to remove it. And there is our answer. So it appears that evidently our new speed limit should be 79.29 miles per hour. And the day that they start doing miles per hour and speed limits in decimals is probably the day I'm just going to give up and get a self-driving car and never drive myself anywhere ever again because I will definitely get caught. Okay, so that's all I've got for you today. So I'm hoping you notice the difference is that we are now using the probability options to take a probability and get back to a score, which is something that we have not done previously. But the earlier questions were very much like what we had seen earlier in this section on probability. It was, oh, I have a value and I know the distribution. What's the probability? So all the problems in D and E like we're doing is going the other way. All right.